Assalamu alaikum students. Hope everything is fine at your end. So today we are talking about fundamentals of chemistry, lecture number 3. In previous lectures we have studied about branches of chemistry, atomic number, mass number and relative atomic mass. Today the topic is empirical formula and molecular formula. Now the question arises, what is empirical formula? So a formula gives the proportion of the elements present in a compound but not the actual number or arrangement of atoms. Second question arises, what is molecular formula? A molecular formula gives the actual whole number ratio of atoms of each element present in a compound. For example, there are actually 2 hydrogen atoms and 2 oxygen atoms in each molecule of hydrogen peroxide. So H2O2 is the molecular formula of hydrogen peroxide and HO is the empirical formula of hydrogen peroxide. Now, empirical versus molecular formula. What is the difference between them? So first of all, we are looking for the definition. What is empirical formula? Empirical formula is the simplest form of formula that we can write for a molecule. And molecular formula is the formula showing the type of atoms and number of each atom connected in the molecule. Empirical formula gives the simplest ratio of atoms in a molecule, and a molecular formula gives the exact number of each atoms in a molecule. What about molecular mass? Empirical formula cannot get the exact molecular mass, but molecular formula can get the exact molecular mass. What about the predictions? Empirical formula can predict the type of atoms in ionic compounds, but molecular formula can predict oxidation number of atoms, their reactions, and end products of reactions. So what about the uses? Empirical formula is used for simple molecules, for crystalline ionic compounds, and for polymers. And molecular formula is used for covalent compounds, but not for macromolecules and ionic compounds. So this is molecular formula of glucose, C6H12O6, and this is the empirical formula of glucose, CH2O. Now, self-assessment, example 1.2. Write the empirical formula for the compound containing carbon to hydrogen in the following ratio. So first is 1:4. This is CH4, carbon 1, hydrogen 4. Second one is 2:6. So CH3 is empirical formula. 2:2, CH is empirical formula. And 6:6, CH is empirical formula. So self-assessment 1.3. Aspirin is used as a mild painkiller. There are 9 carbon atoms, 8 hydrogen atoms, and 4 oxygen atoms in the compound. So what about empirical and molecular formulas? So their molecular and empirical formula is same, C9HHO4. It cannot be simplified. So number 2, vinegar is 5% acetic acid. You all know that vinegar is C2H4O2. So the simplified form is CH2O. So number 3 is caffeine, C8H10 and 4O2. This is found in the tea, in the coffee. So what about the empirical formula for caffeine is C4H5N2O1. Next is, we are talking about molecular mass and formula mass. What is molecular mass? Molecular mass is the sum of atomic masses of all the atoms present in the molecule. So the term molecular mass is used for molecular compounds. So the molecular mass of water, because as all of you know that molecular mass of water is 18. AMU means atomic mass unit. 2 hydrogen and 1 oxygen. So this is an example 1.3. Determine the molecular mass of glucose, C6H12O6, which is also known as blood sugar. So molecular mass of glucose 6 carbon and 12 is the atomic mass of carbon. 12 hydrogens, 1 is atomic mass of hydrogen, 6 oxygen, and 16 is atomic mass of oxygen. You can see in the periodic table. So the molecular mass of glucose is 180 atomic mass unit. In the same way, you can identify the molecular mass of naphthalene, which is 128 atomic mass unit. So the question arises, what is formula mass? The sum of the atomic masses of all the atoms in the formula unit of a substance is called formula mass. So the term formula mass is used especially for ionic compounds having cations and anions. Example 1.4. So first one is sodium chloride, which is also known as table salt, which is used to flavor food, preserve heat, and in the preparation of large number of compounds determine its formula mass. So NaCl, sodium atomic mass of sodium is 23 and atomic mass of chlorine is 35.5. So overall the formula mass of NaCl is 58.5 atomic mass unit. Second one is milk of magnesia. Milk of magnesia, which contains magnesium hydroxide and is used to treat acidity. So determine its formula mass. Magnesium atomic number of magnesium is 24. Atomic mass is magnesium is 24 and oxygen is 16. Hydrogen is 1. So overall 58 atomic mass unit. Self-assessment 1.4. This is potassium chlorate. It is used commonly for the laboratory preparation of oxygen gas. Calculate its formula mass. So formula mass of KClO3 is potassium 39 atomic mass, chlorine 35.5. Then there are 3 oxygens. So 16 is atomic mass of oxygen. So you can identify the molecular mass of KClO3. Self-assessment 1.4. So when baking soda, sodium bicarbonate is heated, it releases carbon dioxide, which is responsible for the rising of cookies and bread. Determine the molecular formula of baking soda and carbon dioxide. So sodium is 23, atomic mass of sodium is 23, hydrogen 1, carbon 12, and oxygen 16. 16 into because there are 3 oxygens, so 16 into 3, 48. So 84 is atomic mass unit. So formula mass of carbon dioxide is 44 atomic mass unit. Self-assessment 1.4. So following compounds are used as fertilizers. Determine their formula masses. Urea, NH2 twice CO. Actually, the formula is C double bond O, and on both sides NH2 is used. Formula mass of NH2 twice CO is 60 atomic mass unit. So ammonium nitrate, NH4NO3, the atomic mass unit is 80. In the same way, you can identify different formula masses of different compounds in so get ready for homework, students. So what we will do, make a column to differentiate between molecular and empirical formula. Okay. So we'll continue our lecture tomorrow, inshallah, into revised lecture given to you today at home. Thank you so much. Allah bless you all.